Solving by completing the square. So this video we're going to talk about solving a quadratic by using the complete the square technique. So we got this example here. We want to solve this quadratic by completing the square. So we want to find the values for x that will satisfy this equation. The first thing that we're going to need to do in order to use the completing square technique is make sure that our value for a is 1. So whatever the coefficient of x squared is, it's got to be a 1. So usually we would start by dividing everything by whatever the a term is. So for example, if this was a 2 here, we would divide both sides of the equation by 2. For the most part, for algebra 1, we're going to be seeing a is already equal to 1. So most of the time, this step will not be an issue. All right, so we have a 1 here as our a term. If we don't see a number there, it's a 1. Next step, we want to remove whatever constant is there already. So here we have x squared plus 6x minus 3. This negative 3 is our constant. And I need to remove this because as it stands right now, this trinomial is not a perfect square trinomial. This is not the correct c term that I need in order to rewrite as a binomial squared. So I'm going to remove this by adding the 3 to both sides of the equation. So that'll give me x squared plus 6x is equal to 11. Okay, so a was 1, took care of that. We removed the constant. Now we want to add b over 2 squared to both sides. And this is where the technique gets its name, completing the square. I'm going to complete this perfect square trinomial. So my b term right now is 6. So I'm just going to do some side work. b over 2 squared, that's going to be 6 over 2 squared. And that 6 comes from right here, that's my b. 6 divided by 2 is 3. And 3 squared is 9. Okay, so 9 is going to be the number that's going to make this a perfect square trinomial. I'm going to add that 9 to both sides of the equation. Okay, so if I'm adding 9 to this side, I have to add 9 to the other side too to keep the balance. Now that I have this as a perfect square trinomial, I can rewrite it as a binomial squared. So we could factor it using the AM technique, but there is a shortcut. Whatever half of b was, in this case positive 3, that's going to be the number that goes inside the parentheses. So if you were to factor this, two numbers that add to 6 and multiply to 9, you would get 3 and 3. So that would turn into x plus 3 times x plus 3, and something times itself is that quantity squared. 11 plus 9, that makes 20. Okay, so now that we have this as a binomial squared, we can use a square root to isolate the x. So step 5 says square root. So I'm going to square root both sides of the equation. If I square root something that's squared, it will cancel out, and I'll just have what's underneath. So x plus 3 is equal to, and I'm going to remember to say plus or minus the square root of 20, because whenever you're the person to draw in the square root, you have to remember to put plus or minus, because it could be the positive number squared to get 20 or the negative result squared to get 20. Now I need to isolate my x by subtracting 3 from both sides. So I'll have x is equal to negative 3 plus or minus the square root of 20. And sometimes you're able to stop here, but others, like this case, will have some radical that can be simplified. To simplify the radical, we need to find the perfect square that multiplies to what's underneath. In this case, it would be 4. So I'll have x is equal to negative 3 plus or minus the square root of 4 times the square root of 5. And the square root of 4 is 2. So my final answer will be x is equal to negative 3 plus or minus 2 radical 5. So remember, this is representing two answers. We have negative 3 plus 2 root 5 as one root, and then the other root would be negative 3 minus 2 radical 5. All right, let's get some more practice in with these steps. So step 1, divide by a. Well, a is 1, so I don't really need to do that. Step 2, remove the constant. Let's get rid of this pesky 5. We'll have x squared minus 14x will equal negative 48. Now to complete the square, we'll do b over 2 squared. This will take some side work. Negative 14 divided by 2 squared. We'll have negative 7 squared, and negative 7 squared is 49. So since b over 2 squared is 49, this is the number I need to add to both sides. X squared minus 14x plus 49. And since I added it to the left, I need to add it to the right as well. Now I can rewrite this trinomial, that's now a perfect square trinomial, as a binomial squared. So I'm going to have some binomial squared equal to 1, because negative 48 plus 49 is 1. Now the trick to knowing what goes in the parentheses here is whatever half of b was. So negative 14 divided by 2 is negative 7, so I'll put a minus 7. From here we can solve using square roots, so I'll square root both sides. X minus 7 is equal to plus or minus the square root of 1. Now in this case, 1 happens to be a perfect square. The square root of 1 is just 1. So when I add my 7 to both sides, I'll have 7 plus or minus just 1. Whenever we have a perfect square and we evaluate it into just a number, we can split this into two equations and solve for each whole number root. So x is equal to 7 plus 1, or x will equal 7 minus 1, because these numbers can be simplified. 7 plus 1 is 8, and 7 minus 1 is 6. So my two roots will be 8 and 6. All right, looking over at part B. Try this one on your own. Pause the video, and then I'll show you the result. Okay, let's take a look. Step 1, we'll get rid of the 3. X squared minus 2x equals 19. Then from here, we need to do b over 2 squared. So negative 2 divided by 2 squared will be negative 1 squared, which is positive 1. So I need to add this 1 to both sides of the equation. X squared minus 2x plus 1 equals 19 plus 1. Now I can rewrite this trinomial as a binomial squared. And to know what goes in here, I'm going to check to see what half of b was. It was negative 1, so I'll have x minus 1. 19 plus 1 is 20. From here I can solve using square roots. X minus 1 is equal to the positive or negative square root of 20. Add 1 to both sides. X is equal to 1 plus or minus. Now the square root of 20, just like we saw up here before, can be broken down into the square root of 4 and the square root of 5. So I'll have root 4 times root 5, and the square root of 4 is 2. So my final answer will be x is equal to 1 plus or minus 2 square roots 5. Now notice that when we're solving with completing the square, we're getting some of these answers here that are not rational. When we were solving quadratics before using factoring techniques, we were only able to solve those that had rational roots. But here with completing the square technique, we can actually solve with irrational roots. So this is going to cross the x-axis at whatever the sum of 1 and 2 plus the square root of 5 and 1 minus 2 square roots of 5. So these are not whole number roots. So that makes completing the square a little bit more powerful of a technique than factoring.